Welcome to Global Watch. Please subscribe and hit the bell icon for more breaking updates. Picture a tiny, silent vessel drifting beyond Pluto. Voyager 2, humanity's ghost ship in the cosmic ocean. For nearly 50 years, it's been our distant observer, now billions of miles away and nearing its end. But before its signal fades, Voyager 2 has sent one last, astonishing message. A revelation that reshapes our understanding of the solar system. This isn't about a distant star, but about us. About the very bubble of space we call home. The heliosphere. Decades-old data from Voyager 2 has solved a mystery about Uranus, revealing our solar system is more dynamic and interconnected than we ever imagined. This discovery has real consequences for our technology, astronauts, and life on Earth. Voyager's final message is a testament to human ingenuity and our relentless quest for knowledge. Launched in 1977, the Voyagers were built to last 5 years, but have endured for nearly 50, outliving many of their creators. Their last transmission reminds us that exploration is never truly finished. The universe always has new surprises. So, let's follow Voyager 2's signal, traveling for nearly a day across the void, back to a fleeting encounter with Uranus. We'll witness a rare cosmic event, and see how decoding this single moment has unlocked discoveries that ripple across our understanding of the solar system. This is the story of how a ghost ship's last word became a new beginning for planetary science. Voyager's story began with a dream, a rare planetary alignment in the 1970s that allowed a single spacecraft to visit Jupiter, Saturn, Uranus, and Neptune. In 1977, NASA launched Voyager 1 and 2 to seize this cosmic opportunity. Their mission? Explore the outer solar system for the first time. These probes carried cameras, magnetometers, spectrometers, and the iconic golden records, a message to the cosmos. Voyager 1's journey ended after Saturn, heading out of the solar system. Voyager 2, however, continued on to the mysterious ice giants. After Saturn, it cruised for 5 years toward Uranus, arriving in January 1986. Voyager 2 became the only human-made object to visit Uranus, gathering data during a brief, frantic flyby. It discovered new moons and rings, and measured Uranus's bizarre tilt and magnetic field. But it also found something deeply puzzling. The space around Uranus was eerily empty of plasma, a mystery that would baffle scientists for decades. That loose thread would take nearly 40 years to unravel. As Voyager 2 swept past Uranus, scientists expected a magnetosphere teeming with plasma, like those of Jupiter and Saturn. Instead, they found it strangely empty, almost as if the system had been flushed clean just before arrival. This led to the belief that Uranus's moons were dead, frozen worlds, incapable of releasing water ions. For decades, Uranus was seen as a quiet, plasma-deficient system, its moons written off as geologically uninteresting. Yet, Voyager 2 also detected intense radiation belts, second only to Jupiter's, requiring a source of particles that seemed to be missing. How could Uranus have such strong radiation belts with so little plasma? It was a paradox, a roaring bonfire with no wood in sight. This enigma persisted for 38 years, challenging our models of ice giant planets. Was Uranus fundamentally different, or was something else at play? With only a brief flyby's worth of data, the mystery endured. Scientists would need either a new mission or a new perspective to find the answer. The truth was hiding in plain sight. The breakthrough came not from a new spacecraft, but from a fresh look at old Voyager 2 data. In 2024, Jamie Jasinski's team at NASA reanalyzed the 1986 data with modern models and a better grasp of space weather. They discovered Voyager 2 had arrived just after Uranus was struck by a rare, powerful solar storm, a coronal mass ejection from the Sun. Such events, which compress a planet's magnetic bubble, happen at Uranus only about 4% of the time. Voyager 2's timing was a 1 in 25 chance. The solar wind had temporarily scoured the magnetosphere clean, explaining the missing plasma. If Voyager 2 had arrived days earlier, it would have seen a completely different environment. The paradox of the intense radiation belts was also solved. The storm had energized the remaining particles, creating powerful radiation belts. The bonfire wasn't missing wood, it had just been doused with cosmic gasoline. The 38-year-old enigma was finally put to rest, not by new data, but by seeing the old data in a new light. Sometimes the universe's secrets are just a matter of timing, and sometimes the answers are already in our hands. Solving the Uranus mystery does more than close an old case. It reopens the possibility that its major moons are geologically active. The old belief that the moons were inert was based on Voyager 2's failure to detect water ions. But now we know the region had just been swept clean by a solar storm. Moons like Ariel, Titania, and Oberon might have subsurface oceans, making them prime targets in the search for extraterrestrial life. The 2024 findings suggest these moons could have been active all along. Voyager 2 simply arrived at the wrong moment. This discovery forces us to rethink the dynamics of the outer solar system and the sun's influence, even at its farthest reaches. The Uranian system is now seen as dynamic and interconnected, not static and dead. The call for a new mission to Uranus is more urgent than ever, with a dedicated orbiter now a top priority for NASA. Voyager 2 gave us a glimpse. Now we must return to see what wonders await. As Voyager drifts into interstellar darkness, a new guardian takes its place, NASA's Interstellar Mapping and Acceleration Probe, or IMAP. Launched in 2025, IMAP is designed to map the heliosphere, the sun's protective bubble, like never before. Stationed at Lagrange Point 1, a million miles from Earth, IMAP has a continuous view of the solar wind and interstellar medium. Using advanced instruments, it will study the boundary between our solar system and interstellar space with unprecedented detail. IMAP observes energetic neutral atoms, tracing their origins to build a global map of the heliosphere structure. It will answer the big questions left by Voyager. How does the solar wind interact with interstellar space? How does the heliosphere shield us? By connecting Voyager's data points, IMAP will reveal the true shape and dynamics of our home in the galaxy. It's the next step in understanding the cosmic weather that shapes our solar system. The heliosphere is our cosmic shield, protecting life on Earth from deadly galactic cosmic rays. Without it, life as we know it might not exist. Cosmic rays would bombard our planet, threatening life and technology. Understanding the heliosphere's structure is crucial for survival, especially as we rely more on satellites and space travel. IMAP isn't just a scientific mission. It's our most advanced space weather early warning system. From its vantage point, IMAP can detect dangerous solar events, giving us precious minutes to protect satellites, power grids, and astronauts. The Uranus event of 1986 is a stark reminder. Space weather can reshape entire planetary environments. As our dependence on space technology grows, so does our vulnerability. Studying the heliosphere is about protecting our civilization and ensuring we're ready for whatever the cosmos throws our way. Science is a human story, driven by curiosity, perseverance, and the thrill of discovery. Imagine the scientists in 1986, seeing Uranus up close for the first time, then facing a puzzle that would last decades. The recent breakthrough is a testament to persistence and the power of new perspectives. Jamie Jasinski's words capture it best. If Voyager 2 had arrived just days earlier, it would have seen a different Uranus. The universe doesn't always perform on cue. Sometimes, discovery is about being in the right place at the wrong time. As one mystery is solved, new ones emerge. Hubble recently found Uranus's moon sweeping up mysterious dust, raising fresh questions. Science is a conversation across generations, each discovery inspiring the next. Voyager's legacy is not just in its data, but in the inspiration it provides. The journey continues, with new missions and new mysteries always on the horizon. Voyager 2's final message teaches us that exploration is never wasted. Old data can yield revolutionary insights. Our solar system is alive, dynamic, and full of surprises. The fleeting encounter with Uranus's storm is a reminder that profound secrets still await in our cosmic backyard. Every discovery, whether a storm, a hidden ocean, or a map of our shield, adds to the grand puzzle of existence. Space exploration is both a practical investment and a fundamental part of the human spirit. The journey is far from over. Voyager drifts on, IMAP begins its watch, and the call to return to Uranus grows louder. Stay curious. Support discovery. The universe is the greatest story ever told, and we're living in its pages. Voyager's whispers remind us, There's always more to learn, always another mystery to solve. Our journey to the stars has just begun. The greatest discoveries are still ahead.